Okay, welcome back to another engineering economics video. We're going to look at one more example problem in chapter 6 of our textbook, and this is going to be looking at the required savings to justify a purchase. So the example problem is this. We're going to work for a company that's considering purchasing a new piece of equipment that's $110,000. This piece of equipment will be in service for 5 years, and at the end of that 5 years, we'll be able to salvage it or sell it for $10,000. In addition to the cost of purchasing the equipment is going to require operating costs. In the first 2 years, those costs will be $20,000. In the following years, the 3 following years, it will be $25,000. Now, in order to justify the cost of this equipment, we don't just simply want to break even, but we want to make money. We want it to make 15% on its investment. And so we want to know how much are we going to need in annual savings in order to make this investment worthwhile. So I've got a spreadsheet set up here, sort of a template. Let me bring this in. And so what we need to do first is we need to look at our costs over the lifespan of this piece of equipment and find the present values of these values and then add them up. So initially there is going to be a capital cost of $110,000. That's how much it costs to buy the piece of equipment. So that money is an upfront cost, and so I should make that negative. So negative $110,000 is what it's going to cost to buy this piece of equipment. But then at the end, we can salvage it and get $10,000 of that money back. We get a positive income of $10,000. Now, over the lifespan of the equipment, in the first 2 years, it's going to cost $20,000 to operate. And again, I should make that negative because it is a cost. It's an outgoing cost. That's for the first 2 years. And then for the last 3 years, it's going to be a negative $25,000 cost. So let's take a look at what the present value of the operating costs are, given the fact that we have a 15% interest rate. I'll put that down here. 15% is our minimum attractive rate of return. And so what that tells us is that this company expects to make 15% with all of its investments. So if we don't invest in this project, we're going to invest in some other project that's going to make a minimum of 15%. So let's just keep that in mind. But when we look at our operating costs, they change over time. And so we're going to want to find an annual equivalent to sort of smooth out or even out these changing costs over time. So I'm going to write a function here that this equals the present value of, and I'm going to use this 15% interest rate. Now I'm going to want to copy this down, and when I do that, I don't want the cell reference to this interest rate to change. So I'm going to put a $sign in there to lock that into row 11. So that's our rate. The number of periods is the number of years into the future that these costs will be incurred from the point of view of the start of the project. And they're not a payment, but instead they are a future value. And so there we have the present value of the first year operating cost, of the second, third, fourth, and fifth. Okay, and so what we can then do is sum up all of these values. So this is equal to the sum of this column. And so what that gives us is what we call the net present worth or net present value. So we add up the total present value of the operating costs and then spread that back out over 5 years. So this is equal to PMT of, again, we're going to use that 15% rate. The number of periods is 5. And the present value, the net present value or net present worth of the operating costs is that value right there, the $75,675 value. And that gives me an annual equivalent. So basically, I don't know why these cells have so many decimal places. They're just money, so we really only need, there we go, that's better. So essentially what this is doing is taking the place of, since we can't just add these all up and divide by 5 to find an average amount, because we can't do that with these financial quantities that can gain interest over time. So instead, we find all of their present values with our interest rate. We add them all up to find the total value, and then we spread it back out over 5 years using this payment function. So this process is used in place of just simply averaging these values, which we cannot do. That ignores the time value of money, and we cannot do that. So this is our annual equivalent operating cost. So you could kind of say on average, we're spending $22,575 a year on our operating costs. Now I'm going to flip this. It is a cost. It's an outgoing cost, but I'm going to make it positive. I'm just going to use all positive numbers here because all of these values are costs. We're not really considering any revenue in this whole problem except for the salvage value, which I suppose is a revenue. But everything else here is a cost. So the interest rate is 15%. The initial cost that of the investment is $110,000. The salvage value that we get back in the end is $10,000. And so the net cost, what this is going to cost us over 5 years, is equal to what we pay for it minus what we can sell it for. So it's that $110,000 that we paid minus the $10,000 we get at the end. Really, it only costs us $100,000. That's our net cost to us. So if we want to take this cost and spread it out over 5 years, we cannot just simply divide by 5. We need to use a payment function. Use the payment function with our 15% rate. Number of periods, 5. Present value, $100,000. So that, and again, I'm going to flip the sign here. I'm just going to keep things positive. So that's $29,831 is our annual cost in terms of capital costs. This is looking at how much the equipment originally cost, what we salvage it for. So what is that net cost, and then spread it out. So this is the annual equivalent capital cost. But we have to also consider for our total capital recovery the annual opportunity cost, which essentially means that if at any point in this 5-year cycle we had decided, you know what, we're going to scrap this project, we're going to take the equipment and we're going to sell it, and we're going to sell it for $10,000. So at any point in time throughout this project, we could have just given up on the project, sold the equipment for $10,000, and reinvested that $10,000 at a rate of 15%. So we could have earned 15% times $10,000. We could have earned $1,500 at any point in time in this project, but we didn't. We decided not to do that. We decided to keep the project going, and so there is what we call an opportunity cost associated with that. And so these two terms, the annual equivalent capital cost and the annual opportunity cost, go together to make what we call the total capital recovery cost. And this is an annual cost. It's the capital plus the opportunity gives us the total capital recovery cost on an annual basis. So it's going to cost us about $31,000 a year to own this equipment. Now we need to look at how much it's going to cost to run the equipment. What are the operating costs? Well, we had found earlier that the annual equivalent cost of operating it is this $22,575. So this is just equal to that $22,575. And so the total cost to both own and operate this equipment is equal to this value plus this one. Okay, so that is the total cost of owning and operating this equipment. So just to quickly recap what we did here, because our operating costs changed over time, we wouldn't necessarily have we wouldn't have to do this if it was $20,000 a year every year. But since it changed, we essentially need to find an average operating cost. And we can't just add these all up and divide by 5. We need to find the present value of each of them, then add them all up, and then take that total and spread it out using a payment function. That's for the operating cost. For the capital cost, which is the cost of owning it, we need to look at what we pay for it, what we sell it for, and determine the net cost. Spread that out over 5 years using a payment function. And then we also need to look at the money we could have made each year if we had decided to sell it and invest it at the 15%. And since we didn't do that, that's our opportunity cost. And so if we look at the sum of these two values, that gives us our total capital cost on an annual basis. And up here, this average operating cost is the annual operating cost. And so the total cost of ownership is the sum of those two values, how much it costs to own it and how much it costs to operate it. Okay, I think that will do it for Chapter 6. If you have any questions, be sure to ask them in class or post them to the discussion board.